Hi and welcome to this video, which is video 2 in the function series of videos for P1 Mathematics. This video we're going to look at the domain and range. So the syllabus says that we should understand these terms, what the domain and the range are. Last video we talked about one-to-one function, the definition of a function, those sorts of things. So today we're just going to talk about domain and range and being able to find the domain and range. Alright, so here's the definitions. The domain is the set of all possible x values of a function. The range, the set of possible y values for a function. So let's talk about that. If we've got a basic function here, which is the one we dealt with last time, f of x is 3x minus 1. When you look at these, it makes it really easy to kind of work this out. So this is just a straight line. You can see that the set of possible x values is anything. I mean, I could have any x value for this function here and it would work. And same for the y values. Any y value here is possible. If we look, at x values like minus 1 million down here, we've got this really big negative y value. So we'd say in this case that any x value is possible, or we'd say x is an element of the real numbers. So any real number is possible. So just a little side note here on what real numbers are. Rational numbers and irrational numbers. So it's pretty cool if you take any given number and any other number there's actually infinitely many real numbers sitting here between these two, which is pretty cool. So it's just all of the numbers. Any rational number can be written as a fraction, and any irrational number like pi and root 2 and things like that. Alright, so we're saying here the range is any real value, the domain is any real value. So my ways of finding these questions are twofold. Firstly, try and sketch the graph, because if you can see the graph, it makes life really easy. Or the other method is you can kind of look at the equation and kind of nut it out and see if there are any restrictions here on x values or y values, and normally based on the equation you can get it. So let's do a couple of examples. Alright, so we want to find the domain and range of this function here, x minus 1 squared minus 3. So this is a quadratic with a turning point of 1, negative 3. So we know it has a minimum value at 1, negative 3, and if you put x equals 0 in there, you get negative 1 squared. 1 minus 3 is negative 2. So just a quick sketch of this. It doesn't have to be accurate. Obviously this is nice and accurate, but a quick sketch of this graph will really help you to see what the domain and range is. So firstly, the domain. We could have any x value. I know this kind of stops just after 4, but this graph goes on forever. And so we could have any x value in this function and it would work fine. So we'd say x is an element of the real numbers. Could be anything. That's the domain of this function. But you can see that there's a restriction on the range. You can see that the y values, there's no y values below negative 3. None. They don't exist. So the range here is the y values are greater than or equal to negative 3, or you could say f of x is greater than or equal to negative 3. That's probably more accurate because the function was defined in terms of f of x over here. So the other way that you could look at this is you could think, okay, let's look at this function. Let's say, imagine we didn't have the graph. You could look at this thing and say, okay, what are the restrictions on the f of x values? Well, this thing here is a perfect square. So the lowest this could be, the least this could be, is 0. And that happens when I substitute x equals 1 in here. If I put x equals 1 in here, this part here becomes 0. And so the lowest that f of x could be is negative 3. Any other x values that I substitute in there, you're going to get an f of x value that's greater than negative 3. Try 2 in there. Try 3, try 4. Any different, bigger x values are going to give you bigger f of x values. So just by looking at the equation, you can also kind of work out what the range could be, but I think looking at the graph is the easiest. Alright, second example here, find the domain and range of f of x is root 2 minus x. Yeah, having the graph, awesome here. If you know what a square root graph looks like, and you know this one's the idea of functions and transformation of functions, if you can draw this, fantastic. So I can see clearly from the graph here that not all x values are possible. In fact, I can see clearly from the graph that only x values less than or equal to 2 are possible. Okay, anything bigger than 2 isn't possible. And same for the range, the y values. We haven't got any negative y values down here. It looks like if we're looking at this axis here, the y-axis, that we can only see values of y that are starting from 0, that is when x equals 2, and going up from there. So, if you have the graph, fantastic. Let's imagine we don't have the graph and we're just looking at this function here. think about restrictions on x values. As soon as you have a square root graph, you know that you cannot have square roots of negative numbers. That function will not exist at those points. So straight away, if I look at this function here, I know that if I put in an x value like 3, I'm in trouble. If I put in an x value of 4, I'm in trouble. In fact, anything that's 2 or more is going to cause this square root bracket to go negative, the number underneath there, and then when the function is not going to be defined. On the other hand, if you look at it, if you have an x value of, let's say, does 2 work? Let's just check out 2 for a second. Square root of 0 is okay, that's 0, so that's okay. What about x equals 1? Square root of 2 minus 1, square root of 1, that's okay. What about x equals 0, square root of 2, that's fine. And keep going. X equals negative 2, 2 minus negative 2, square root of 4, that's fine. So it looks like everything from 2 and below is going to be okay. And I'm just looking at the equation here. So I'm saying that the range here is going to be x values less than or equal to negative, sorry, I beg your pardon, the domain. So the set of x values less than or equal to negative 2. Same thing for the range. Look at this thing here. It's a square root graph, so we know straight away that for a square root graph that the lowest it can be, this thing here is going to be 0. What values can we get out of here? Well, it's the square root. It's got to be a positive number. So when we get x equals 2 here, we get f of x equals 0, and that's the lowest it can be. Any other x values, then f of x here is going to be bigger than 0. So I can say straight away that the range here, the possible y values, or the f of x values, is greater than or equal to 0. So you can see there's two ways. If you have the graph, fantastic, but you also can nut it out just by looking at the equation and thinking about it. Alright, last example here. Let's say we've restricted the domain, and so you've got to be careful about this when we restrict the domain. So in this question here, find the range of this function given the domain is x is greater than or equal to 0. So again, a sketch is really important here. If we can draw this graph, and I've drawn x squared plus 2x plus 1 down here, but in this question here, we can see the range is just values greater than or equal to 1. So you can see that we could have any y value if it's greater than, or f of x value if it's greater than or equal to 1. But the question says we're only talking about x values greater than or equal to 0. So from there on. So we're only talking about this part of the graph here. Alright, so let's zoom in here. So we're only talking about the blue part of the graph here. So I can clearly see for that part that the range, the possible y values, are 2 and above. So f of x could be greater than or equal to 2. A sketch is often really helpful here. If you don't have the sketch, what I would do is substitute in that value for x, which is x is greater than or equal to 0. Put x equals 0 into there, and you see that f of x is equal to 2. Put x equals 1 in there, and you see that you'll get 5 out of there. F of x will be equal to 5. Put x equals 2 in there, and you see that f of x is getting bigger and bigger. So that kind of gives you an indication also that the f of x values are 2 and above in this case.